Okay, so let's start working this one. This is, we're starting right on the hour, so we may end a little bit early. Um, this is taken from the homework, the second one. The third one looks a lot like it. Um, we'll deal with that shortly. So it says this rod, OA, this is the rod right here, um, rotates clockwise, that's this way, with an angular velocity of 6 radians per second. The two-pin slider block located at B, and if you zoom in on this, it's a little bit of a pixelated image, but this contraption right here is allowed to slide up and down this brown rod, while simultaneously this brown collar here slides back and forth on the blue rod. So it says the two-pin located slides freely on OA and on the curved rod, and is shown and it follows this path. R is equal to 200 2 minus cosine theta. Determine the speed at 120. Hang on a second. I'm going to have to pause this. Okay, sorry about that. So this is the equation. Determine the speed of the slider block at 150 degrees. So this will be way over here, but this is probably a reasonable representation of 150 degrees. So again, we go back to the book, and what we see is the set of equations like this. If you run back over here, we could rewrite it. R dot UR plus R theta dot U theta. So really, all I really need to know are R dot. I'm going to go ahead and keep R double dot theta theta dot and theta double dot. In this set of equations, I really don't need that one except to know its location, 150 degrees. And so now comes the issue. And what I'll do is move off to the side over here maybe to solve this. So I have r as a function of theta. I don't have r as a function of time. If I had r as a function of time, I could just basically do dr dt, but I don't. I have it some other particular way. Um, Now, there's two ways to look at this, and that is term by term and in general. So let's do this way. Okay, so since r is a function of theta, we can list it this way. However, I can't take that derivative, but I can take this derivative. This term just simply becomes theta dot, which actually was given here. It says it's a constant angular velocity. It says it's 6. Since it's constant, that is 0. So all I'm left with is these. Now, if we look at these for a second, hang on. What we'll first do is take the derivative, copying this down, of 200, 2 minus cosine theta with respect to theta, and then theta dot. You can carry this down further if you wanted to. 200 cosine theta and I guess I'll carry the theta dot as well. And I'm probably going to select this and move it over to the side after I'm done. So this is a constant, doesn't yield you anything. This one is not. So derivative of cosine is minus the sine. So I'm going to go ahead and carry all of this. And this is just going to be minus the sine. So a minus gives you back a plus. So 200 sine of theta and then theta dot. So this would be r dot. Some people might feel more comfortable. Putting this term in front of that term, and if you are, then that's maybe better as far as just looking at it, aesthetics. Then let's see, I'll zoom this down and try to see. So if I go over and write this in an equation form, I'll see that I have 200 2 minus cosine theta. Over here in an equation form first is 200 theta dot sine of theta. Now what I'm going to do is just move this out of the way, and I'm going to begin to work on the next phase of this in this little area, and I can move it out of the way when I get done. And that is, if I'm looking for r dot dot, or the derivative of r dot with respect to time, which in fact is this. Now I'm going to go term by term. Now, the reason this is so different than the one before is this r dot is a function of theta and theta dot. Now, you can list this out in a generic mathematical form, or you can just do it one at a time. And that's what I'm going to do here. I'm going to take the 200 out. Okay, so what I'm doing is extracting this out the outside, and then I have two things that are products of each other. And you list that out. The next step, of course, is to carry out the integration here, and the integration here just yields theta double dot. So with that, you can basically, and the derivative of sine is cosine, you can basically look at the 200 theta double dot sine of theta plus, and we'll go ahead and put the 200 theta dot cosine theta. Now, the typeset's a little bit different, but what I'm going to do just copy that over, and then get that out of the way. And your next key is something you have to be mindful of. If, I'm going to recopy this equation, if you're looking for velocity at theta is equal to 150 degrees, that's of course equal to r at theta is equal to 150 degrees, sorry, r dot, ur, yes, at theta is equal to 150 degrees, plus r when theta is equal to 150 degrees, times theta dot when theta is equal to 150 degrees, times u theta when theta is equal to 150 degrees. So in fact, generally people don't write this part, but this is sometimes implied and not really talked that well about. And so the next step is to list these in this way, and that is r, I'll say all at 150 degrees, and put the whole box down here, and I'll say r is equal to 200 times 2 minus, just making sure I copy that right, cosine 150 degrees. That'll give you a number. Then you have r dot, which will be 200. Now, what I'm going to do is I'm going to drop down r double dot, and then I'm going to do theta, that's 150 degrees. Theta dot is equal to 6 radians per second, and theta double dot is equal to 0. So what I'm going to do in this is I'm going to use these three terms here and here, and of course here and here. And with that, you get times 0 times sine 150 plus 200 times 6 times cosine 150. This is the only term that is not 0. This one is 0 because of that. Then you come back to r double dot. I'm sorry, that was r double dot. Now you come back to r dot, which is this term. and that's 200 times theta dot, which is 6 times the sine of 150. So in all these, you get a number, a number, a number, of course, a number, and a number, and a number. So, of course, the thing you do is here. The velocity goes to r dot. I'm just basically recopying this thing without the terms on there, the functional terms, or theta dot u theta, and what I end up with is the number that comes from here. You can just list them as number 1, 2, 3. So this would be the number 2, the one that was our dot, ur plus r, which would be the number 1 up there, and then theta dot, which is just 6, which is given to us, u theta. Essentially, you just put in this number, multiply these two, and you've got your answer. Technically, if you look at this, okay, so I'm going to assume that this drawing is geometrically correct for the moment. And what I will do is I'll go in here, I'll recognize at this particular point, this is the UR vector. This one, which is perpendicular to it, length 1, is the U theta vector. Now, I can get components of these and list them, but what I should end up with is a vector which is tangent to this blue path. And it should come out right there. And that's the geometric representation. Now, if you wanted to convert this vector to the ij, you would have to really look at what these two vectors look like. And we'll talk about that later. So if you want to do the acceleration, which is a fairly simple term in the regards of what we've already listed, you go to the next page and you will see this. Okay, so what I'm going to do, collect both of these, move to the next page, right here, just sort of drop it, say right there. Oh, it is fairly tiny, so what I can do, increase its size and move it over. Now, if you compare this term up here, these are all my terms, and what I'm going to do, I'm going to do this. I'm going to do a copy. Up. It did not. Okay, I'm going to do a copy. Now, I'm going to go down here and say put it right here. If I'm looking at this, this is all I need to do. And let me look at the length of this here. So everywhere I see an R, put an R. Everywhere I see an R dot, put an R dot. Everywhere I see an R double dot, I put that number in there. Of course, there is no theta. There's a theta dot right here and right here. And I didn't include the R that was right there. And then my theta double dot, which goes right there. So again, these will be 6 numbers. Once you use your calculator to determine those numbers, this one you don't even need. So in fact, there are 5 numbers. R dot, R double dot, theta dot, and theta double dot. Those are the 5 numbers you need. You need those if someone asks you at 150 degrees. You need to know each 5 of those at that 150 degrees. And then you just simply put them in here. Again, the thing is exactly the same in regards to the fact that the coordinate directions here, I'll get them. Let me see if I can get this picture in here, and okay. So if we look at this picture, and we head back over here, drop this picture in here. What you will notice again, this is u sub r, this is u sub theta. So let's say you end up with a sub r equaling to 2 and a sub theta equal to minus 4. So that would put a vector that would look like, if that's the unit, if this is unit length, this would be 2 out in the r, and you'd have a vector that would basically go in this direction. So this would be 4, and this would be 2 from here to here, and with those 2, your vector would look like this. It'd be a straight line, but it would look just like this. I don't know that these are the answer. I doubt they are, but this is the geometric interpretation. Once you get these numbers, these 2 numbers, this is how you put them on the diagram. There is no tangency with the acceleration. There is exact tangency here, in that this vector right here has to be tangent to the path that it's taking. And that's pretty much it. I don't really want to go into the next section yet. I think I did. Looks like I did a lot of that, or all this already. So let me do this real quick. Go ahead and open the computer is fairly slow. I'm going to go ahead and open. I'm going to open the next 2 weeks, I think. 6 and 7. And we go into 6. Next week, we're going to be covering pulleys and relative motion there. And I'm going to go ahead and take this out, but I think we have enough information in there already. So I think I'm going to go ahead and shut this live stream down since it went a lot quicker than I thought, and we'll just go from there.